Good morning. We are going to explain this now. Okay, so what's that? First, I explained in class why we need three support forces or three constraints. Basically, because if we have more, we can't calculate it. And if we have less than or fewer than two forces, not three forces, this will move and we don't want this structure to move. For example, if we have two rollers, we have one vertical force or one vertical constraint. Here we have another vertical constraint, but we don't have three, we only have two. So if we apply this force, this object will move. If we have a hinge here, we have a vertical constraint, we have a horizontal constraint. If we have a roller, we have a vertical constraint only, but here we have two and here we have one. So there's three support forces or there are three constraints so that this doesn't move. If we apply a horizontal force, it doesn't move. And if we apply a vertical force, it doesn't move. So that's why we need three support forces. And we're going to solve this structure. We have two forces applied here, and we have this geometry. So I have put a number on this force. The vertical one is 50, the horizontal one is 30. And we have this geometry with those triangles. We have A and B. This is the hinge, this is the roller. And then we have all these points, and we have to calculate equilibrium at each point, and then we can calculate the internal force that all these cables or bars are suffering due to the external forces that we are applying here. So that's the goal. Okay, let's do it. If we know what happens here first, we have to calculate the effect of the external forces on that geometry and the effect that those external forces have at these points. So we have to calculate the support forces or the constraints that we have at point A and at point B. So instead of drawing the roller, I'm going to copy this, and that hinge is, what is it? It's gonna be a force, like, okay, so when we have a hinge, we have two constraints, one going up and the other one horizontal, one vertical and one horizontal. And if we have a roller, I can delete this, and the effect of this roller is just a constraint, a vertical constraint. Now the thing is, does it go up or down, leftwards or rightwards? Well, if we look at geometry of this and we look at the forces that we have, if we have a vertical force here, most likely a vertical force going down, most likely the reaction that we have in A and B will go up. But if it doesn't, we will find out when we calculate that because we will have different signs. Okay, so I'm going to apply an arrowhead, and okay, I want this to go rotate. So I want this to go up, and I'm going to copy this one here. Now I have to give a name to these two forces. And since we are at point A, I'm going to name this reaction A. Y, usually the vertical axis is Y and the horizontal axis is X. Okay, so this is AY. And what about this one? This is at point B. It's vertical, so I'm going to call it B, Y. And now we have to name this one. It's at point A, so that will be A. And since it's horizontal, I will name it X. Okay. That will be A, X. And what's the sense? Where's the arrowhead? Like this. Okay, if we have a horizontal force going leftwards, most likely this will be rightwards. So now we have translated with a pin or a hinge and a roller into forces. So these AX, AY, BY are external forces applied on this. Okay, so we have these external forces, but since we have constraints, constraints are. I have a question. No, we have to find equilibrium. So equilibrium, the external equilibrium. We're not talking about equilibrium at this point. We are talking about the equilibrium at this level, at the structure level, or at the object level. Okay, so imagine that all this rectangle is an object, and these external forces should be counteracting each other. What is the equilibrium? We have also equations. So we can go here. That will be, there's always vertical equilibrium. There will be horizontal. And there is equilibrium in the moments. It's about the rotation. Okay, so it cannot move vertically, it cannot move horizontally, and it can't rotate. So there's a third equation, which is the moment. There will be three equations and we have three unknowns. So that's why we need only three constraints. If we have more constraints, we don't have more equations. We only have three. So we know the same amount of constraints or unknowns as the equations that we can set here. What is the vertical equilibrium? What is going up? AI plus BY, sorry, AY plus BY. And this is going up, and what goes down? 50. So vertical equilibrium, we have AY plus BY equals 50. 50 goes down. Okay, so that's the equation of vertical equilibrium. What about horizontal? Horizontal is pretty straightforward. What goes left? 30. 30 is the force that goes leftwards. What goes rightwards? AX. Okay, so AX in this case, we can calculate it very easily. And finally, what is the moment? Okay, so that's more difficult. And to calculate the moment, to calculate rotation, we need dimensions here. Okay, so we're going to set dimensions. So this is going to be 100. This is going to be 100. And this is 100. If we have squares, we're going to need the angle. So the angle will be 45. This one and this one. This is very easy because all dimensions are the same, 100, 100, and this diagonal, the angle is 45. Okay, so what is the effect? And now we have to select a point at which we have to calculate the equilibrium. What's the effect of this force at this point? It's 0 because we have a magnitude, we have AX, but the distance between the force and this point is 0. The same thing, AI. We have a magnitude, but if it's applied at this point, the effect is 0. So it's AX times 0. But BY, if we apply BY, then the whole structure will rotate in this direction. Okay, so we have BY, and the effect of this is that this is going to rotate in this direction. What's the effect of this force, 30? If we apply this force here, how does it rotate? It's going to be the same. If we apply this at this point, what's the effect of this force? It will rotate in this direction too, okay? Because this is pushing in this direction. So if we didn't have anything to prevent this from happening, that force will make this structure rotate in this direction. And finally, what's the effect of this 50 force going down? What's the effect at this point? So that will move the structure in this direction. Okay, so we have two forces moving the structure in this direction, and then we have one force moving the structure in the other direction. So in this moment equilibrium, we have to put at one side of the equation everything that moves the structure in. This is counterclockwise, and that moves the structure clockwise about this point. So let's do it. What's the effect of BY? BY on that structure. So it depends on the distance between BY and point A. And what is that distance? 200. So BY times 200. That moves counterclockwise. 30 moves the structure counterclockwise. So I add this plus 30. And what's the distance? It's the perpendicular distance to this point. So the distance of this line to point A is 100 times 100. And this is everything that moves that structure, that rotates that structure counterclockwise about this point. So now what makes the structure rotate clockwise? So what makes equilibrium? This 50, this force. And what's the distance between this line perpendicular to this point, or the distance perpendicular to this line about this point? So it's 100 too. So that will be 50 times 100. So that's the equation of equilibrium when it comes to the moment, to the rotating force that we can have here. Okay, so we have three unknowns, AX, AY, BY, and three equations. With this equation, with the horizontal equilibrium, we can calculate AX. AX is 30. Okay, so we can type here that equals 30. That's pretty easy. I think we can calculate easily BY, because BY with this moment, we have BY times 200 equals 50 times 100 is 5,000. And then this is positive here. It goes to the other side of the equation as a negative number. So this is 30 times 100 is 3,000. So that would be 3,000. So what is by? 5,000 minus 3,000 is 2,000. Then this 200 moves down, divided by 200. So how much is this? By equals 10. Okay, so now by is 10. We have by, and we can calculate ay here. So that's pretty easy. Ay will be down. Ay equals 50. By is 10, and it goes to the other side of the equation as a negative number, negative 10. So ay equals 40. So if I'm not wrong, ay equals 40.